Mesdames et messieurs, ladies and gentlemen, veuillez accueillir, please welcome Anita Sengupta en conversation avec In Conversation with Valérie Bertheau.
Right. Good morning. I am Valérie, and I have the great pleasure to interview Anita Sengupta from Airspace Experience. And really, we are going to talk about a great topic, not really technology, but more societal. We're going to talk about multimodal urban transit and society. You know that more than half of people are today living in cities. It accelerates. And there are a lot of people still living in rural and suburban areas. And for them, accessing to urban city centers of bigger cities is really a challenge because they do need that for their education, to access to employment, to access to healthcare, and it's really a challenge for their development. So, Anita, can you tell us what is your view about this topic and how your company can solve this problem?
So it's definitely a huge challenge, and I personally live in Los Angeles, which is probably one of the most congested cities in North America, and most of my family lives in India, and cities in India are some of the most congested cities in the world. So when you look at people who live either in the suburbs of Los Angeles or outside of the suburbs of Los Angeles, or my family who lives in Kolkata and Mumbai, who live in rural areas, people are looking at hours every single day to be able to get to their place of work, to their place of school, to be able to get access to services. So we know that it's a real challenge. And I think this is something which would bring the community together to come up with a good technology solution, a green technology solution. And I believe one of those solutions, of course, is mass transit on the ground with things like high-speed rail and hyperloops. But another solution, which deals with the congestion aspect of moving around in suburban urban centers, is the use of the 3 dimensions of airspace. And so my company, Airspace Experience Technologies, is developing a electric vertical takeoff and landing aircraft, which would allow you to move at 5 times the speed of a traditional ground transit to be able to get you from distances far away in rural areas, in suburban areas, to the city centers. And I think the key to doing this, of course, is doing it in a smart way, a green way, and a clean way so that we can also reduce our carbon footprint.
All right. We have questions from the audience, and I really like the very first one. So, is there an issue in having a multiplication of planes in our sky?
So certainly, if we imagine a future which we might see in things like the Jetsons or other forms in science fiction where you see many, many different flying cars in the sky, people might call them, we would need to have an update to existing air traffic control to handle that density of traffic. But I'm also a pilot. It's something that I do for fun in addition to my primary job with my company. And there is air traffic control which already governs instrument flight rules, visual flight rules, which provides spacing between aircraft. So initially, when we would roll a system out like this, you could use existing air traffic control. But certainly, something 10 to 15 years in the future, you would want to add in a more autonomous aspect to air traffic control so you can support a higher density. So autonomy developments that you see in the automotive sector couple very nicely to autonomy, which could come in an urban air mobility situation.
Talking about autonomy raised the question of security and safety and also data privacy. So what is your perception of this?
So for me, as someone now working in the transportation sector, human safety is the most critical requirement that we can possibly work to, whether that's in ground-based transportation or in aviation-based transportation. And so the aspect of autonomy in aviation actually can improve safety because you can do traffic management and collision avoidance using a computer, which is inherently more sophisticated than a human being's reaction time. So you do have that ability to make things safer, but of course that requires that you know positional information location of where a person is to be picked up with one of these on-demand aerial systems, and positional information of each aircraft in that system. So you do have to have a certain amount of information related to where you are in 3 dimensions to be able to support that. So we have to make sure with our regulations, with our governments, that this information is only used for autonomous transportation, collision avoidance tracking service, and isn't used for anything else like advertising and sales and things like that. So I think that's where the government needs to come in from a regulatory perspective to make sure that that information isn't misused.
Linked to that, there is a matter of trust. Because having people accepting to go on board in an autonomous aircraft potentially, how do you imagine that we can have people accepting to go in and comfortably feeling positive?
So I think autonomy, just as with cars, as with airplanes, has to be rolled out over time. So there would be no urban air mobility system which would not have a pilot in the loop initially. So our aircraft is being designed for 4 passengers and 1 safety pilot. And so you would always have a pilot in the loop for many, many years until different agencies such as the FAA or the Canadian equivalent or the European equivalent would approve something different. But in all scenarios, you would always have an operator on board. Whether or not that operator 15 years from now needs to be a trained pilot is kind of up for debate. But I will say, for those of you who do travel by air currently, at least in the United States in airspace, when you're above a certain speed, above a certain altitude, you actually have to turn the autopilot on. And the reason for that is the airplane does a much better job at maintaining your altitude, your position, your attitude than a human being can. So it actually improves safety from aircraft separation perspective to have an autopilot above a certain speed, above a certain altitude. So we sometimes take those things for granted and don't realize that they're already happening, but it's actually improved aviation safety quite a bit.
Mm-hmm. Indeed. Coming back to societal impact, people living in rural areas usually have less money than people living in big downtown cities. One question about the accessibility and the affordability of such multimodal solution.
So I spent most of my career working for the space program, which happens to be very expensive vehicles, right? They're not done with how do you think about making something super cost effective. Now, over the past 2 years, I've transitioned over to transportation systems. And your end use customer of any transportation system is the person who's writing it. And in order to make a transportation system useful and affordable, you have to get the ridership up, which means that it has to be something that people can afford. And so in the context of an urban air mobility system, the only way that's going to happen to get the ridership that you need is to make it affordable. And so you do that by bringing the price point of the vehicle down so that it's more like an Uber ride. And so what we're developing at my company and other companies around the world actually is vehicles that are really less than $1 million per vehicle, for example, and therefore that would translate onto a price point for a shared ride service, which is more like an Uber or a Lyft or a cab ride, a taxi ride, and so that it becomes more affordable in that sense. And these are always shared ride platforms where each seat is occupied by somebody. Otherwise, they wouldn't actually be used. It wouldn't make any sense to have a single person. So the way you bring down the cost is to increase the ridership as well, and also to make the vehicles made in a more cost-effective way.
Mm-hmm. So we are talking about the positive impact of the multimodal mobility from rural to cities. But what about the environmental impact and the noise impact?
So certainly one of the biggest challenges that we think we have in the transportation sector is that we're doing a great job at making electric cars, making electric buses, trains, and high-speed rail already run off of the grid. And therefore, if the grid is run off of renewables, then you have a lower carbon footprint. So what we haven't done yet is to shift to the sustainable aviation mindset. And so this is where electric vertical takeoff and landing actually come in a really nice niche industry, because the urban suburban use case, which is shorter range, right? It's not hundreds of miles, it's 100 miles to 200 miles or even less, can have battery-only aircraft. So you can have electric aircraft for this urban suburban use case, which then kickstarts the electric aviation industry. And so what we really have to do is to complete the electric vehicle space to include aircraft such as urban air taxis, which is I'm referring to, take that up to regional jets, perhaps with hybrid electric systems or fuel cells, and then eventually take that up to transatlantic jets. So we have to reduce the carbon footprint of all modes of transportation, and aviation is the one sticking point. So as a pilot and as an engineer, it was very important for me to be able to start a company that would make strides along making sustainable aviation a reality in the next 5 years.
Mm-hmm. Linked to that, there are many questions in the audience, and I will take the shortest one, which is a bit tough. Isn't it an elitist solution of transportation?
Isn't it a
elitist?
Oh, elitist.
Yeah, sorry for my French accent.
Well, that's really important, whoever brought that question up, because I am not a wealthy person. I'm an engineer. I've been an engineer my whole life. I always wanted to be a pilot since I was a small girl. And what people don't realize is that flying small airplanes, which is what I fly, are not actually that expensive. So I could go to a trip to Santa Barbara with my 4 friends in a small airplane, and it doesn't cost any more than driving. So most people don't know that because they don't fly small airplanes. And the whole purpose of my company is actually to make air mobility accessible to everybody by bringing the price point down. And one of the things that you have to worry about when you're talking about a new mode of transportation, like when I worked for a Hyperloop technology company, now with an urban air mobility company, is to communicate to the public why this is something that they can actually use. And there's nothing more invigorating and exciting than to see the bird's eye view of the world. So by bringing the price point down of these electric vehicles, because they're battery powered, they have low maintenance costs, low operational costs, low fuel costs, you can actually make urban air mobility accessible to everybody. And so one of the biggest markets that we're looking at is actually India. And India obviously has a much lower income level for an average household than we have here in Canada or in the United States. So I'm specifically looking at targeting people who live in these urban, suburban, rural areas and something that they can afford.
Definitely there are many questions about this accessibility and the affordability. And a broader question about transportation problem and congestion. Do you think that we should more focus on air solutions to minimize transportation problems?
Aerial solutions?
Yes.
So I think we have to focus on all solutions. So I'm definitely not a fan of focusing on one thing. So I think mass transit is key, shared rides is key, getting people out of individual cars is key, shifting over to scooters and to bicycles is key. So multimodality is just that. You have to think of every available solution. And I myself try and spend as much time as I can riding a bicycle in Los Angeles and taking the train. But there are certain places where you can't do that because the routes don't exist or they're too slow. So we have to think of all mobility solutions, not just one.
All right, okay. And coming back to the multimodality, it raised the question of the interoperability. And because having multiple means of transport for a long period of time implies to have a good and smooth, seamless interconnection between all these means of transport. So how do you think you could solve this question of interoperability and having the right way to work in ecosystem?
So I think there's 2 aspects to that. One is a very basic technology solution. So if anybody has an iPhone or an Apple device, it's kind of annoying because the iPhone and Apple device has a unique interface for all of its different hardware and it doesn't connect with anything else, right? So that is an intentional non-intermodal solution, for example. So if we can come up with transportation solutions which actually share hardware and interfaces among them that actually supports multimodality in terms of if I can charge my airplane at the same place that I charge my electric vehicle because we're using the same battery pack with the same interface, all of a sudden it becomes easy to transition from an infrastructure perspective from one to the other. And so our use case actually with our aircraft is to use as much automotive technology as we can from a diagnostics package perspective, LiDAR, radar, from a battery perspective, from a powertrain perspective, so you can use them for cars, buses, trains, or airplanes where it makes sense. The other aspect to it is the on-demand solution space. And so everybody now probably does rely pretty heavily on shared ride services they call with an app on their phone. That data layer can couple to multiple modes of transportation. So one of the things that we worked at my last company was ways to couple getting off of a train to calling a shared ride service to booking an airplane ticket. So that on-demand model where you can actually figure out where people need to go, you can actually couple them together in that software application space to give you that seamless solution. And even now, you can pick up, for example, a scooter, an electric scooter, after you get off of a shared taxi ride and go from there. So I think coupling that software application environment to ways that you can have common interfaces between different technology solutions helps to lower cost as well and make it easier to have intermodality.
And connected to the interoperability topic, what is the role and what should be the role of government?
Oh, from a regulatory perspective?
Yes.
So I think government regulation is key. I think that you can see examples of, let's say in the drone case, for example, where there weren't regulations first, and then all of a sudden people have to scramble to create rules surrounding drones and becoming a drone pilot in drone airspace. So it makes a lot of sense for technology companies or technologists to work hand in hand governments to make sure that as the technologies are being rolled out, that there's a regulatory framework that can accept them. And so this is something that we worked on quite a bit at my former company, which was a Hyperloop technology company, because there was no regulatory agency for a Hyperloop. And this is something that we're also working on in the aviation space with the FAA, for example, to make sure that we get updates to regulations, whether it be on how do you certify the vehicle, because it's battery powered, how much reserve fuel or battery percentage do you need for IFR, VFR flights, and then how do you operate a system which is an on-demand service as opposed to a traditional commercial service? So I think the technologists, the technology companies working hand in hand with the regulators, meeting up in environments and conferences like this. We're having a conference next week in DC, actually called Uber Elevate, where we're all getting it together between the regulatory side, the Uber side, the Lyft shared ride side, and the aviation side to make sure that we're speaking and moving ahead together in unison to make it happen.
There are multiple questions from the audience about the scalability of your solution and how can it become a real mass transportation solution compared to bus, train, etc.
So in terms of how we're scaling it out for our company is we're looking at having 50 aircraft in 50 urban centers in the United States, which gives you a total of 2,500 aircraft by 2025. So that's a way that you can roll it out. Something which I can't speak for Canada because I don't live here, but I can speak for the United States, is that everyone's used to the commercial hub airports, right? Like Montreal, like Detroit, like LAX, like JFK. In the vicinity of all of those commercial hub airports in the United States, there are many general aviation airports which are underutilized, but existing infrastructure which is already funded and operated by the government. So our solution is to actually make use of those existing general aviation airports, taking traffic away from the congested hubs that you currently use and shift to that model to do city-to-city flights, regional flights, and eventually cross-country flights. So that way you can utilize an existing infrastructure asset, which happens to be the most expensive part of any transport system, and actually remove congestion away from where we currently have it around hubs, which then couples to congestion going in and out of those hubs. So this is actually a solution which solves a larger solution of airport congestion by shifting it out. Now, the reason why it's very different way of thinking urban air mobility is that we always think about traffic and congestions in two dimensions. When you think about urban air mobility, all of a sudden you now have the three dimensions of airspace available to you. You have highways in the skies. You've sort of opened up that space. You've removed that congestion by an order of magnitude for the low altitude airspace solution. So that's the reason why it does a lot to address congestion, for those two reasons.
I have a simple question with many votes. What are the advantages compared to an helicopter?
That's a great question. So there are vertical takeoff and landing is the ability to literally take off and land from this platform with a smaller footprint. A helicopter, which is a rotorcraft, can do it. A tilt rotor, which is another type of aircraft, which is part of our space, can do it. Or ours, which is a tilt wing, can do it. The advantage of a tilt wing aircraft is that it has the ability to take off and land vertically, but when it cruises like a fixed wing airplane. And there's nothing more aerodynamically efficient than a fixed wing airplane. A rotorcraft or a helicopter is not aerodynamically efficient during cruise, and a tilt rotor is not aerodynamically efficient during cruise. And the reason for that is they don't have a large wing, which is essentially how you generate lift when you're in cruise. So we're able to reduce significantly over a slightly larger range the amount of energy which is consumed. And since we're focused on an energy efficient solution, you obviously would want to go with the technology choice which uses the least amount of energy. The other advantage is that you do have the ability to take off and land at airports, which means that If you can take off and land at an airport, you want to, because it's a more energy efficient way of doing it. You use most of your energy during the vertical takeoff and landing component. And then the other aspect is that when you're a fixed wing aircraft, you're essentially a glider. And so when you learn how to fly an airplane, the way they teach you how to land is they actually pull your power from your engine. Because it's easiest to land an airplane when you don't have any power, because you just have to glide to land. So it's inherently safer because it has that lifting body architecture with it. And the other aspect, which is it's sad, is that there's not enough pilots in the world. And if you take a look at the increase in passenger flights, no matter what model you use, there aren't enough pilots to support it. A tilt-wing aircraft has the ability to have a fixed-wing aircraft pilot. It's not a rogocraft, so you don't have to have a helicopter license to fly it. You can have a fixed-wing, multi-engine aircraft license to fly it. So it has a bunch of advantages on that front.
Oh, very clear, thank you. The very last question. What is your dream for future multimodal transportation having a very positive impact from a societal point of view, but also from an environmental point of view?
So I personally think that the largest challenge that we face as a society, as a people, as earthlings, is climate change and our impact on the environment because of CO2 production and all the things that go into CO2 production, whether it's direct emissions or manufacturing processes. So my view of our planet going forward is that each of us has to do something to reduce our carbon footprint. And I think because it's something that I can impact as an aerospace engineer, the idea of being able to reduce the carbon footprint of air travel by starting with this urban use case to create electric aircraft, which are charged off of the grid, which hopefully comes from solar or wind, then shifting to battery or hydrogen fuel cells for regional aircraft, and then eventually shifting to even higher density hydrogen fuel cells for transatlantic aircraft is a way that we can do so much to reduce our carbon footprint in the transit space. And so my vision is to be able to have a way to connect everybody with these low carbon footprint solutions, at least from the aviation space. I also am a huge supporter of all modes of ground-based transportation, which are high speed and therefore accessible to people in rural environments, such as the Hyperloop, for example. And so that's the way I think that if we focus on mass transit solutions, shared ride solutions with a low carbon footprint, we can go a long way to reducing our impact to this earth and then protect our planet.
Thank you.
Thank you.
Thank you very much for having shared your vision and how Airspace experience intend to support this challenge. Thank you.
Thank you so much.